Hi, I wanted to come in here and record a little video about how to use Desmos for some of the statistics tasks that you will be doing in the second half of Module 1. I have created a list here of 28 elements. Notice that to make a list, you have to first start by labeling your list, putting an equal sign, open up the bracket, and then typing your numbers or copying them on from an Excel sheet or even a document or from within your homework system. If you just copy and paste, it'll create a list. And then you can start working with it. The other thing that I wanted to point out is that there is a keyboard here that you can pull up, and then you can use that, or you can just type using your laptop as well. So the first thing I want to show you guys is how to find some of the one variable statistics that you will need. One of them is the mean. So I'm just gonna type mean and then parentheses, and then the letter A so that it refers back to my setup here. So notice that the average, the mean is the same thing as the average, is 62.428 and so on. When my data has no decimals, my statistics are gonna have, I'm gonna round them to one decimal. So I would give the answer of 62.4. I'm also gonna show you how to find something called the median. That is another measure of center. And again, it's given to you as 68. Then I'm gonna find something called the standard deviation. Standard deviation has an abbreviation of STDEV, and again, of A. My standard deviation would be 27.1 if I round it to one decimal place. One other thing that you'll have to do is build your 5-number summary. 5-number summary is composed of the maximum, the median, the minimum, the first quartile, the median, the third quartile, and then the maximum. If you have the list in front of you and you can tell what the minimum and the maximum are, you don't have to find them, but this will help. Minimum of A is 12, and maximum of A, maximum of A is 99. If you wanted to find now the quartiles are going to be basically breaking up your data into 4 parts. So the first quartile will be is the number that separates the first 25% of the data. The second quartile is basically your median because it separates the bottom half from the top half. Third quartile is separates the bottom 3, like the 75th percentile, the bottom 3/4 of the data from the rest. So quartiles are going to be using this kind of code, quartile, and then again A, and then if I want the first quartile, I put a 1. That's for quartile 1. That quartile 1 is 42, and then if I put quartile 2, that should give me the same thing as the median, because quartile 2 is basically 50%, and the median, notice that was 68, and so this is giving me 68 as well. So instead, I'll give you the third quartile, which is the 75th percentile, the data value that separates, or the value that separates the bottom 75% of the data from the top 25%. So these are all one variable statistics that you'll need in the second half of Module 1. Then you're also going to be asked to make some graphs. One of the graphs is called a box plot. A box plot uses that 5-number summary. So let me show you. Actually, let me go back to a dot plot, which you used earlier. So dot plot of A, you'll see it here. So you can, and then also if you don't get a good view, sometimes you don't get a good view here, you can always click on this zoom fit, this little plus sign, and it'll give you a better view. This one is already pretty good, but there it is. It looks a little bit better now. It just zooms it in to make it the data more relevant. Notice that some of the values, like this one right here, 78, shows up 3 times. We would call that the mode, the value that shows up the most. Here's your maximum. Here's your minimum. Okay, and then notice that in this case, the median is 62.4, so it's about right here, whereas the mean is 68, okay? We'll talk about spread in a little while as well, and when I make a histogram out of this. The next thing I want to show you is the box plot. So the box plot, again, of A. Notice that is a box plot is composed of the minimum, the first quartile, the median, the third quartile here, and then your max. They're overlapped right now. I want to have it a little bit higher. So this offset here tells me how high to put it. So I'm going to put it about here. So I'm going to put it a 4. So now you can see it a little higher. Let's see. That's fine. Notice that the smaller a region in the box plot is, the more concentrated the data is. So there's more data here than there is, for example, here. This one is longer, but it's still 25% of the data. So you're seeing the bottom 25% of the data being more spread out than, say, this one right here, okay? Another one, the last thing I want to show you here is how to create a histogram. So a histogram, again, just type histogram. And then notice that it's asking you for a couple of things. The data set, so that's A. And then by default, it makes a bin of 1. That bin of 1 is basically making you bars of just 1. So each bar represents one data value or one value. So that's not very useful. It almost looks the same as my dot plot. So if I wanted to increase my bin to, let's say, to go by 5s, then it looks like that. But that's still too many bars. I think in this case, I would like to see it more like a 10. The other thing I like to do is always show it with the alignment to the left. So what that does is it gives me the view right here from 0. And let me again do like a zoom fit. That looks much better. So this is from 0 to 10, from 10 to 20, and so on. Okay. Notice that this graph right here looks like it's skewed to the left because we have a big concentration of data here and less data to the left. So there's a tail towards the left. This would be skewed to the left. When the data is skewed to the left, we see, let me see. We see that the mean is going to be to the left of the median. So our median right here was 68 and our mean gets pulled towards the tail. So these low values right here are pulling the mean down. Okay, then let's see, one more thing that I wanted to show you, the bar height. The bar height here is telling me how many values there are in each bar. So here, see those 2 dots, that's those 2 values. Here I see 3 dots, that's 3 values. If I wanted to have what we call relative frequency would mean out of 28 values, I have 2 here. So 2 divided by 28 would be my relative frequency. Let me just see what 2 divided by 28. So that's 0.07. So if I redo this histogram so that it gives me the height as a relative frequency, that means that instead of seeing a 2 here, I would see a 0.07, or in other words, like a 7% of the data being in this bar right here. So let me try that. I'm gonna click on relative. Now that looks really tiny. So once again, I'm gonna click on zoom fit so that it gives me a better view. And notice if I click on this, let's see. Actually, I'm not sure if I click on it, if it's giving me the value. But you can see here, we were expecting it to be like 0.07. So here's 0.05, 0.06, 0.07, there it is. So that's basically going from a bar height of count to a bar height of a relative frequency, okay? That's all I have for you guys today. I hope this was helpful. I'll record more as needed, hopefully before you get to the lessons. And as usual, let me know if you have any questions by just email me or send me a message through the Canvas inbox. Bye.